It's your friendly math tutor, Miss C, here to talk about sine functions. Today we're going to look at something called amplitude. So normally when we look at a sine function in its most basic form, we're looking at an equation of y equals sine of x or sine of theta or sine of beta, whatever variable. What you're going to notice about what we're doing today is we actually have a number being multiplied by our sine function. When we see equations like this, where there's a number multiplied by the sine function, it means that we have an amplitude. That's this word right here. And what amplitude technically is it is a vertical stretch. So it tells us how many times bigger or taller, you could think of the new sine wave being. So in this case, our amplitude is 3. So if you look at the green graph represents y equals sine of x. So if I kind of do this, y equals sine of x, or sine of theta in this case, you're going to notice that my highest value is positive 1 and my lowest value is negative 1. When I look at my blue graph, this is the graph of y equals 3 times the sine of theta. You're going to notice that my maximum value or my highest value is 3 and my minimum value is negative 3. That is 3 times the size of the original value. So when we're graphing these, the way we can tell what the amplitude is we always look at, in a regular function that has no shifts, which we haven't gotten to yet, you're going to look at 90 degrees and 270 degrees, and you're going to look at the y value. And the amplitude will be however many times 1 that value is. So in this case, 3 is 3 times 1. That means the amplitude is 3. So what you're going to notice is my wave is taller and shorter, I guess. And the distance, maybe shorter is not the right word, but it increases in size positively and negatively at the same rate. So my total distance goes from 1 to negative 1 to 6, because we're going from 3 to negative 3, with each one of them having a height of 3 from the x-axis. Let's go ahead and start by solving our first equation, our first sinusoidal equation that has an amplitude. So first things first, I'm going to do what I would do normally when I'm solving any trig equation. I'm going to look at the domain that I am solving within. Remember, sine waves go on infinitely, so we have to know the part of the wave that we're looking at. So this tells me I'm looking at all values from and including 0, so that is here, all the way to 360 degrees. This should be a reminder before we get started to adjust your calculator so you are in degree mode, making sure that you are not in radian mode. So we know that we are only looking for answers within this domain. Now, the other thing that I'm noticing is I have no negatives. So the other piece of this means that I am looking for values, or not I'm looking for values, but my values will fall between these two green areas. So we're only looking at the parts of the graph that are positive. So that graph that I just highlighted is the graph of y equals 3 times the sine of theta. And when we get that simplified, the other graph I'm going to look at is right here. So remember, that amplitude of 3 stretches our graph by 3 times. So that's why the new maximum is 3 instead of 1. So normally, when you solve just a sine of x equation, right, and there's no amplitude, you have to make sure that your value that you're solving for is between 1 and negative 1. In this case, because we have an amplitude, we need to make sure that it falls between 3 and negative 3. 2 certainly does that. And then I'm going to double check again before I take the arc sine of both sides. Once I get sine of theta by itself, that value that it equals then falls between 1 and negative 1, and then we'll take the arc sine. So the first thing I'm going to do in solving this is to try to get sine of theta by itself. To do that, I am going to divide the 3 from both sides. It's the inverse operation of multiplication. So when I do that, I get the sine of theta equals 2/3. So remember, once we get sine of theta on itself, on its own side by itself, I'm now looking at this yellow graph. And I'm looking to see that this value is between 1 and -1, which it is, so we are set to move on. My next step is I'm going to take the arc sine of both sides. So real careful here, I'm not multiplying, I'm taking the arc sine. So remember, the arc sine of the sine of theta is just theta. And then I'm going to take the arc sine of 2/3, and I'm going to pop that number in my calculator. And when I do that, I get 41.81 degrees. All right, so that is about right here. Now, I know that I have two values within this 180 degrees. So to find the next value, which is going to be exactly symmetrical on this part of the graph, I'm going to say 180 minus the 41.8 degrees that I found. And when I do that, I get theta equals 138.19 degrees. And that is my second solution. I now have two solutions. To be absolutely certain that I did this correctly, especially if I did not have a graph, I would want to go ahead and pop these into my calculator. So what I would do is I type 3 sine of 41.81 degrees into my calculator, and I should get out approximately 2, and then I would do the exact same thing to both of these. I know it's a little tedious, but you can use the back button, especially if you use a Casio, to just back out the degrees and then put the new one in, and that's super fast. And what you're going to see is that you are getting these 2 points, so they're exactly symmetrical. And these 2 points represent where the y values are the exact same value of 2/3, and you're going to notice that the x values are different. All right, one problem solved that has an amplitude, and now we're going to move through a few more. All right, we're going to start solving our next equation. So we have 4 sine of, that variable is alpha, equals 3. So like we always do, we are going to start by looking at our domain, and we are once again within the domain of 0 and 360 degrees. So our solutions are going to fall within this domain. I'm also noticing that I once again don't have any negative numbers, which means that I am going to have solutions that fall between 180 degrees and 0. So both of my solutions are going to fall within that 180 degree chunk of space. So let's go ahead and start solving. So like we did last time, I'm going to get sine of alpha by itself as my first step. To do that, I'm going to divide by 4 on both sides. That leaves me with sine of alpha equals 3/4. As a check that this is correct, I now have sine of alpha on the left side by itself, which means whatever sine of alpha equals has to be between the numbers 1 and -1. 3/4 is definitely that, so it meets that criteria. Now we are going to take the arc sine of both sides, and I'm just doing this as a little shortcut because we've done this already once. So when I do that, the arc sine of 3/4, I'm popping into my calculator, making sure that I am in degree mode, and I am going to get 48.59 degrees out. That is my first solution. Okay, we know the rules because we've already done them. If you need a bigger explanation, go to my first sinusoidal graphing video. So we're going to apply the property where we say 180 less the value we just got, which was 48.9 degrees. And that is going to give me my second x value that has a y value of 3/4. And when we do that, I get 131.41 degrees. All right, so if I just wanted to make sure that I did this correctly, my first value is about right here. Boy, I'm not having very good accuracy trying to get that on my graph. And my second value is about right here. So they should be exactly the same distance from here and here. When we do that, I would still double check this by popping this into my calculator. So I'd say 4 sine of both of these values. And what you're going to find is that you get approximately 3. Let's do another one. All right, we have a slightly different problem now. So I'm noticing a couple of different things. First, my domain is different. I'm only looking for solutions within the domain of 0 degrees to 180 degrees. So these are the solutions that I'm looking for. This graph also looks a little weird. It kind of looks like a double helix. So the other graphs we've seen have just looked like they've been stretched and were taller. This looks a lot different. And part of that reason is because this is negative right here. So that negative reflects our sine wave over the x-axis, and then it gets stretched by a factor of 2. All right, so a couple things as we do this. I am noticing that I'm looking for a value of positive 1. So without adjusting this, and I noticed that my blue graph, which is the graph of negative 2 times the sine of theta equals y, doesn't have any positive 1 values, right? Because this is the graph between 0 and 180 degrees. Okay. So that's something we need to think about. We're going to talk about that more later. So let's go ahead and move our amplitude and our reflection over. So I'm going to do that by dividing negative 2. So we're getting sine of theta by itself again. Okay, equals negative half. So this is the form that we know, right? So I do know that half falls between 1 and negative 1. I'm back to looking at this graph. Okay. Here's what's interesting about it. This number is negative. I am looking again at the part of the graph that falls between, I've got a lot of colors going on here, that falls between this 0 degrees and 180 degrees, and it has to be negative half. Well, there is no negative value here in this part, only positive values. What this means is within this domain, there are no solutions. So we could say something like no solutions within this domain. And that's the answer. It doesn't mean that there are no solutions ever. What it does mean is there's solutions here. There's a value of negative half, right? There, right? There's 2 values. It just doesn't fall in the part of the graph that we are looking at. Okay, great. All right, our last problem, and we don't have a graph on purpose because we're not always going to have a graph that's available, but we could visualize a graph. First things first, we're going to look at our domain. We are looking for values between negative 360 degrees and 0. So if you remember, we kind of have something that looks like this. Oh my, where did that go? Undo. That looks like this. Don't know what I did there. Okay, what that means is we're looking at this chunk of the graph, okay, from 0 to 360. We've been looking at the positive side for the domain, and this time we are looking at the negative side. The other thing I'm noticing is that my amplitude is 10. So that means that the highest point or the maximum point on my graph is 10, and my minimum point is negative 10. 3 falls between that. Okay, and now we're just going to proceed the way we always have. I'm dividing by 10 on both sides. When I do that, I get the sine of theta equals 3/10. And you know the drill by now. We're taking the inverse sine or the arc sine of both sides. And when I do that, I get the inverse sine of 3/10. Popping that into my calculator, I get my first value of 17.46 degrees. So fine answer. It's like right here on my graph. That isn't within our domain. So we'll deal with that in just a second. Okay, the next thing that we are going to do is we're going to use our property. Okay, we're going to say 180 degrees less 17.46 degrees to get our next value, which is 162.54 degrees. This also does not fall within our domain. It's about right here. All right, so what we need to do is we need to find the values that are exactly 360 degrees the opposite way. So here's how we do that. I am going to take theta, my 17.46 degrees, and I am going to deduct 360 degrees from that because remember, I'm looking for the value that's 360 degrees the other direction. When I do that, I get negative 342.54 degrees. That falls between 0 and negative 360 degrees, so that is a solution. I'm going to do the same thing with my other values. So I'm going to say that theta, oops, I'm going to do it up here, equals 162.54 degrees less 360. I'm subtracting 360 degrees because I am trying to go 360 degrees in the other direction. So that's why I do that instead of the opposite order. So theta in this case equals negative 197.46 degrees. Okay, you want to check these answers by popping these into your calculator. So I would say 10 times the sine of negative 342.454 degrees, and I should get approximately 3 out, and I do that with my second value as well. Thanks for solving sinusoidal function equations with me.